All right, so today's section is section 6.10. Okay, graphing radical functions in standard form. So graphing can always be a little tough, but I've always tried to give you guys a formula that helps you kind of identify where specific things are so you can do it a little bit faster than picking like 10 points and plotting all of them and connecting the dots. I used to hate when teachers used to make me do that. I felt it was a waste of time. I didn't know at the time that it actually was a waste of time because there are formulas that you can use, right? So I'm going to introduce you guys to the formula for this one. I've shown you guys formulas for absolute values. I've shown you guys formulas for quadratic, so I'm going to write those here just to remind you guys, okay? So I've shown you those formulas already. And then I'm going to show you how the formula today relates to those, okay? So just a real quick recall, okay? So we're going to recall. We were graphing absolute values at one point. All right. Now, bear with me because I'm going to change some colors here and there. But this is the way the formula looked like that. This was called the vertex formula. Okay. So we had A. I don't know if you guys remember it. Parenthesis. X minus. Anybody remember what letter was next? H. Yep. Quantity squared plus, what was the last letter? K. All right. So, all right, absolute value function. What am I doing? That's not absolute value. That's quadratic. Absolute value looks like this. All right, that was the absolute value function. Okay. Then we graph the quadratic function. Now remember, absolute value functions look like the letter V, right? Like a V opening up, maybe down if A was negative, right? If you want, I'll even draw it, but it looks something like this. Okay. So they look something like that. Now, we also did quadratic. Okay, and quadratic functions look very similar to what I just wrote. It was y equal to, there was an A here, parenthesis, x minus, and I actually wrote this by accident up above. But notice there's no real difference other than instead of the absolute value symbol, it's now a parenthesis with a square. The A term was called my amplitude. It made your graph either grow faster, like maybe instead of a normal looking V, it was like a really thin V or a really wide V. For this one, it kind of looks like the letter U, right? So it kind of looked like this. If A was positive, if A was negative, it opened down. HK was my vertex for both of them. You guys remember that? HK was my vertex. So it would tell me for the absolute value where the pointy part was, right? And for the quadratic, it would tell me where the lowest point was, right? The bottom of the graph or maybe the top of it, depending on how it looked. All right, so A was my amplitude and HK was my vertex. Okay? So, how am I going to put this together with what we're doing today? So let me kind of put that right here. So today, we're going to do the radical function. Okay, and the radical function is still going to look kind of similar. I get y equal to a, and then we're going to do square roots. We're not going to do cube roots. We're just going to do square root. X minus h, and then plus, and then a k. And these graphs look like this. Okay? Where this little point right here, that's your HK. And if you want, I'll even put that on the other graph. So this would be your HK right here. And on the top one, your HK would be that pointy part right here. So notice how all three functions are pretty much the same thing. They just have a different symbol where the x minus h is, right? The x minus h for absolute value has vertical lines. That tells you it's an absolute value. For quadratic function, it has a parenthesis squared. That tells you it's a quadratic function. Okay? And for today, we have the radical function, and it still looks the same thing, just that x minus h is in a square root. Okay? A still basically tells you whether the graph is opening up. A negative. This is going to be A is positive. It'll look like this. This will still be HK. But this is if A is negative. Okay, it's upside down. All right? But it's just like a little half part of a parabola. Okay? Just that it's opening sideways. Instead of up and down, it's going left or right. Okay? So that's what we're kind of experiencing with those types of problems. Okay? So graphing can always be a pain, but if you know this formula, it's pretty easy. Now, you may have to do a little bit of calculation, but not a whole bunch. Okay? So let me get into some of these examples. Now, we're going to do the easiest one first, just so you can see how it looks, and then we'll start moving into different ideas. Okay? So here we go. This is going to be example number 1. We're just going to graph. Okay? Or actually, that's sketch. I always prefer the name sketch. So sketch these functions. Let's not graph them because I don't want them to be perfect, but I want them to be close. So example number 1, we're going to sketch y equal to the square root of x. Like I said, we're going to go easy as possible first. I'm not going to make a huge graph. If you're ever wondering how big of a graph should you draw, which, by the way, they're going to give you all graphs on your homework, so don't worry about it. But if you're ever having to do it by yourself without anybody graphing them for you or giving you a grid, always find your little vertex value first, because that tells you where at least you have to have points. So I know my vertex here is, well, I won't say it out loud. What is my vertex? What's my HK? 0, 0, right? HK, oh, let me change the color here to show work. My HK is 0, 0. Okay? So there you go. There it is. So as long as I have that, I'm good. Now, my A is positive. That means that the graph is going to go like this. So I could literally just do this and be okay with that. I'd be fine with it. But the thing is, I want you to be a little accurate, okay? Just a little bit. So think of some numbers that you can plug in. You know it's going to the right, okay? So don't pick -1 or -2, because notice the picture that I drew, it's going to the right. So give me a number. We can start at, we already used 0. Give me a number that has a square root that's to the right of 0. Huh? Well, 49 becomes a 7, but notice I don't have 49 dots. So I don't want to go that big. I can try 4 becomes a 2. What else? 8 is too big. I don't have enough for 8. There's another number smaller than 4 that has a square root. 1, right? So if x is 1, I'm going to plug it in right there. If x is 1, my answer is 1, right? So 1, 1. And right now I'll make a little chart so you guys can see it. And what if x is 4? My answer is 2. So 4, 2. And then I'm done. All I basically did was I plugged in 2 numbers to the right side of my HK. All right? So I had to pick numbers kind of like, I had to think about it. Sometimes you can't pick numbers because your graph doesn't let you. But if you can, it'd be nice if you do it. Okay? If you can't, that's okay. Just sketch. But notice, I was able to pick a couple numbers. They worked. I'm done. That's my sketch. Okay? I'm done. As usual, people say, like, do I have to pick numbers? You don't have to, but sometimes your graphs don't resemble the best option. Okay, so let me give you another example. So sometimes picking a couple points could be good. For example, number 2. We're going to do y equal 2 square root of x minus 1. I'm going to draw a little grid here for myself. I'm just kind of setting this up really quick. What's my HK for this one? Is it -1, 0 or 0, -1?
0, -1.
0, -1, right? 0, -1. All right. So I'm going to go to 0, -1, put a dot right there. Now I know my A term is a positive 2, right? So A is positive, which means the graph's going to look like that. It's going to open up to the right side going upward. If A is negative, then it opens down. Okay? Just kind of curious, looking at your homework, do we ever get a negative? Yeah, we do. So we'll make sure we do one of those. Okay. So I'm pretty much good. You could blindly just do this and I'd be happy with it, but let's be a little bit more accurate. Okay? So I want to pick a number to the right side of that red dot, an x value to the right side of it that has a square root. So can I use x equal to 1? Is there a square root to 1?
Yeah.
Yeah, so let me make a little table. I'll pick a 1. Okay? If I pick a 1, what's the square root of 1? Well, that's 1. 1 times 2? 2. 2 minus 1? There's 1. So, all right. So at 1, 1, there's a point. Give me another number to the right side of that has a nice square root. 4, right? Now, in case you're like, man, I got to think all these, remember, 1, 4, 9, 16. Now, at this point, we're going really far, unless you want to draw a graph with 49 tick marks, okay? I would say maybe this might be your lowest level you want to go to, okay? 1, 4, and 9, okay? Because those have square roots. But sometimes it differs based on what's inside. So, but usually those are the ones you're looking at. So if I plug in a 4, what's the square root of 4? 2, and 2 times 2, 4 minus 1, 3. So at 4, it should be 3. So here's my graph. Now, I don't know if you remember, but earlier I said if you did this, I'd be happy. But is that like the right graph? It's off, right? It's off by a lot. That's what I'm saying. Sometimes you might want to pick a couple points just to be a little more accurate. Example 1. Oh, because I messed up. Thank you. A is positive. It's funny because I put negative, yet I drew it the right way, right? Going upward. So I don't know. Brain fart, right? So yeah, thank you for that. Yeah, A should be positive. We'll do a -1 in a bit. Okay, maybe after this now. But I mean, drawing these isn't too terrible. Okay, you're just going to pick a couple points and try to calculate their values. Again, not necessary really to pick points, but it is helpful to get a better looking graph. Okay, because if you just would have stuck with the first one that I drew, I would have been really off. Okay, so sometimes picking a couple points is helpful. All right, so let's move on to something that's a little bit different. Still the same idea. Don't worry, we're not like changing everything and making you relearn some stuff. But the way they write it is sometimes a little weird. So I'm gonna let you guys see it and then see how we kind of change it. But here's one of them. Now they don't always write it like this, but sometimes it happens. Okay. Now, I don't know if you can tell, but my K is in front of my radical, right? Usually the K is supposed to be in the back. So if I were you, which I would definitely do if I were you, I would rewrite this just so that I feel more comfortable with what I know. Because I know HK, I know K is at the back, so I don't want to think about it in the front. Okay? So I just kind of rewrite it. I put the square root in the front, I put the -2 towards the back. I didn't add or subtract to both sides. No, I just literally moved them. Okay, that's all I did. Now, let me just write my HK, then I'll put my answer, my graph there. So HK is what? 3, -2. Yeah, remember, it's always opposite of what you see inside, right? So it's a +3, and then your K value is a -2. So let me go ahead and draw a grid. Now notice, my HK is at, oh, how did I make that pop up so quickly? Did I get rid of it somewhere else? No, that was weird. Whatever I did, I need to remember because that was amazing. I didn't have to take extra time to draw it. All right, so I'm making this one a little bit bigger because of the fact that it's at 3, -2. So it's going to be to the right and down a little lower. So I'm giving myself a little bit more space. So 1, 2, 3, 4, 5, 6. Again, you guys are already given graphs already, so you don't have to worry about, what you should draw. You might want to take note at the scale that they give you, because sometimes instead of it being like 1, every dot being 1, it might be 2. So pay attention to the graphs they give you. So here we go. I'm going to put a dot at 3, -2. So 3, -2 is right here. Okay? And I know my A is positive, right? Because it's a +1. So next one we're going to do is going to be negative, just so you can see what that has a negative value. So that means that my graph is going to look like this. Okay? It's going to grow that way. So all I have to do now is pick numbers to the right side of that. Okay? Well, I don't want to draw a whole bunch of extra ones. Remember, the ones I told you is try 1, 4, 9, 16, 25. You can try 49, right? But those are too big. Can I try 1 for x? No, because I want to go to the right side of my point, not to the left. The graph doesn't exist to the left side of that red dot. So right now I'm at 3. So what would be my next point that actually has a square root? Bigger than 3? 4. So let's try a 4. Okay? But look what happens when I try a 4. Let's see. Let's see what happens. Not that anything bad's going to happen, but let's just check it out. So y is equal to the square root of 4 minus 3 minus 2. So now I get to subtract, right? So now I actually have to do a little bit of math in it, not just naturally get answers from it. So we're subtracting. We get 1 minus 2, which is -1. So that means the point is 4. At 4, I got -1. It has to be a square root of something, yeah. Oh, you're saying at the very end? That gives you a 9, yeah. Good, so that was going to be my next point. So what she's basically saying is, hold on, so then I got to think ahead. I'm not just going to pick 4, 9, 16. What I want is I want the square root to become like a 1, a 4, a 9, a 16. That's what I want. That way I can take the square root of it. So I picked the number 4 when I did this because I knew 4 minus 3 is 1. And 1 has a square root, right? My next square root would be a value of 4, right? So what minus 3 gives me 4? What minus 3 gives me 4? 7. So my next point would be using a 7, right? So I know I have 3, 4, 5, 6. So there'll be, I'll put another little extra thing right here for 7. Because if I try a 7, minus 2, 7 minus 3 is 4. And the square root of 4 is 2, and 2 minus 2 is 0. So at 7, the y value is 0. So these are a little trickier because you have to plan ahead. You got to think, okay, I don't just want to use any number. I want to use a number that when I either add or subtract to it, whatever they're making me do, it ends up in a nice number that's a square root. One of these numbers right here, right? We're hoping that it comes out to one of those, a 1, a 4, a 9, etc. Okay? So you sometimes have to think like, okay, I can't use a 4, just a 4, because it doesn't work. But maybe if I try an 8, then all of a sudden magically a radical 9 pops up and I can do that. Okay? So when you're thinking about what to plug in here, think about like what gives me the result of a 1? What gives me the result of a 4, of a 9, of a 16? Okay, that's what you're thinking when you're plugging in numbers, okay? That's what makes these a little bit tougher because you do have to think ahead. You can't just like 1, 4, 9 all the time, 1, 4, 9. So here's one that's a little bit tougher, right? I'm going to show you one other one here and then I think we'd be good on it. Maybe we'll do 2. We'll see. But let's do one that's negative. This will be example number 4. So y equal to negative 5 square root of x minus 2 plus 4. Just curious, if I double tap it, so if I tap it, it comes out automatically. That's cool. Okay, didn't know that. I've been using this program for 6 years. Had no idea that if I just tap it, it's going to just appear. All right, what is my HK?
Negative or 2.
Yeah, here we go. 2, 4. Let me go ahead and put a dot there. So 2, 4 right here. Okay, so there it is. A is negative in this case, right? That means the graph's going to look like this. Okay, instead of going up, it's going to arc down. No real difference other than just going down. All right, I got to pick numbers to the right side that are going to give me results of 1, 4, 9 in a square root, right? So notice right now I have square root of x minus 2. So let's try getting a 1. A 3, right? 3 minus 2 is 1. So if x is 3, let me plug it in. If x is 3, then I get negative 5 square root of 1 plus 4. That's negative 5. The square root of 1 is 1, and negative 1 times negative 5 is negative 5 plus 4. So this is negative 1. Notice the big jump with that one. It's literally going really sharp down. Now, does that make sense? Well, yeah, because it's being amplified by 5. It's 5 times as fast. It's growing 5 times as fast. So, all right, what's the next number I can try? So I already tried a result that gave me a 1. What gives me a 4? A 6. 6 minus 2 is 4. Square root of 4 would be 2. So that's good. I'll try a 6. So y equals negative 5 square root of 6 minus 2 plus 4. So y is equal to negative 5. Square root of 4 plus 4. The square root of 4 is 2, and 2 times negative 5, that's negative 10 plus 4. Negative 10 plus 4 is negative 6. So at 6, 1, 2, 3, 4, 5, 6, I'm going to be at negative 6. That's 1, 2, 3, 4, 5, 6. My graph looks like that. Now, some people will basically say, well, it's an upside down graph. I'm just going to make it look like that. Notice how bad that would be if you just guesstimate, right? So pick a couple of points, at least one. At least one. That'll give you a pretty decent idea. Okay? Yeah, so exactly. So, in case you guys didn't hear Arlen, she said, so just the inside of the square root, we're trying to make sure that the inside becomes either a 1, a 4, a 9. Yes, that's the trick to doing it, okay? You gotta, don't just pick wildly, because if I pick 7, 7 minus 2 is 5. I don't know the square root of 5, right? So I gotta think, well, we tried a 3, we tried a 6, those worked great. The next answer would be, so that resulted in 1 and 4. The next one would be a square root of 9. So if I wanted a square root of 9, what number would I put up there? 11, right? So then I would pick 11. If I wanted a 16, I'd pick an 18. 18 minus 2 is 16. So I can keep going from there, right? But obviously my graph is not that big, okay? So, so yeah, this is basically what your homework is. You're gonna find your HK, that's the most important part. Figure out whether it opens up or down, that's your A term. And then once you know those, then you gotta pick. Now, notice the only time that it gets tricky is when there's something in here. If that's just radical x, you don't have to overthink it, right? Look at the ones that we did in the very beginning. For that one, I just picked 1 and 4. I didn't think about it. I just said 1 and 4. Those have square roots, right? I did the same thing with this problem. I just picked 1 and 4. I didn't worry about it. But then I got x minus 3. And now I'm like, okay, now I have to think, what gives me a 1 when I subtract 3? 4 does. What gives me a 4 when I subtract 3? 7 does, right? So whenever you have stuff on the inside, that's when you have to think a little bit more. When it's just an x, you don't have to worry about it. Just pick 1, 4, 9. Those will always work. Okay. But when the inside gets busy with an extra h in there, then you have to try to figure out a better number. All right. So let me give you guys your homework. If you have any questions, please let me know. Don't forget, guys, Delta Math already started again. You have till March 10th. It has 30 less questions, so it's a lot shorter.